If you're looking for news related to the conference Civo Navigate Europe, then this episode is for you. Welcome back to the Easy Deliverable YouTube channel. Today's episode is a bit special because we are live here from London at Civo Navigate Europe. As usual, I will try to deliver a few interviews, present a couple of new solutions that I just discovered, and walk through the atmosphere of the conference. If you enjoy today's content, don't forget to like and subscribe to the channel. So follow me at Civo Navigate.
Just finished my keynote at Navigate, so I'm here now. So for people that have seen me speak before, it's not about Kubernetes, but it's kind of been about my career over the last 25 years. I'm retired now, and so I chose to give people a bit of context about my career over that time period. So we covered a lot of ground, what it's like to be a software developer, playing the game on single player mode, to zooming out and seeing the big picture. When you retire, for me, I realized that you're still working. You just get to work for yourself. And so that could mean simple chores around the house, cutting the grass, washing dishes, or giving more attention to those side projects. So I think for me, number one is just learning some things, right? Working this long, you spend a lot of time learning how to work. And so now that I'm retired, I'll spend a little bit more time learning how to live.
If you had an advice to any new engineers that want to start their career in the cloud space, what would be your top 3 recommendations?
Learn the fundamentals. It's like, what are you going to learn in the cloud native space? So sometimes you'll just go look at the CNCF landscape. You'll see all the little logos. There's hundreds of projects there. And I think a new person will feel overwhelmed. They're going to think they need to learn everything that's on that landscape. And it just isn't true. So maybe you're just entering the industry and you work at a company, and maybe they're using none of the things on that landscape. And maybe you're feeling like, hey, I'm left out. Everyone is doing this. The truth is, everyone isn't doing that. And a lot of the things that those logos on the landscape represent, the fundamentals and the stuff that you already have, even if you're working on mainframe. Data comes in, it gets processed, and it goes back out again. That's a fundamental you should learn. If you're just using something like Nginx or Apache web server and you're looking at the cloud native landscape and they're talking about Envoy and service mesh, but even if you were just to focus on Nginx and Apache, 90% of the fundamentals that you learn with those two tools will translate even into the world of service mesh. So I would say if you're new, be patient. You only get to be new once, so why rush it? Learn those fundamentals, don't get distracted too much. And when the opportunity does come to learn one of the things that are there, make sure you go deep and look at the fundamentals and not just the new and shiny. And I think you have a really long, successful career. So don't over-optimize for the new, optimize for the long term. Should I work on open source? Should you work, right? So the reason why we work sometimes is because we need money. So we apply for the job, we take the job, we get money in return. Some jobs you get the benefit of also gaining experience that sets you up for the next job and hopefully more money. And so open source is also a form of work, if we're being honest. And so you got to decide if you want to spend your time there. And if you do, what are you going to get out of it? So when we think about contributing, there's always this giving motion. I can go fix the documentation. I can add a new feature. Or I can fix a bug that I ran into. But it's still work. And if you treat it as work, then you'll be responsible with your time. Because I think a lot of times if you don't treat it as work, you can burn out. You start contributing with no set boundaries. There is no 9 to 5 in open source. It happens 24 hours a day. And so you got to be careful. You got to set boundaries. It's okay to have goals, even When contributing to open source, you might say, hey, this week, I just want to improve the docs. I'm not going to get distracted by the 50,000 open issues on my favorite project. I'm going to pick and choose. I'm going to have a strategy. I'm going to have a plan. You also can think about impact. What is the impact of this change? Do I really use this, or am I just fixing bugs so I can rise up in the ranks of maintainer status? There's so many things that people are motivated to do when contributing to open source. What I would say is go in with a strategy. Sometimes the strategy literally is, I just want to build my reputation in the open community, and hopefully that leads to a better job. It's okay to have that strategy, but also know when to stop. Some people start contributing to a project because they use it at work, and they just want to fix bugs so it can be easier to use at work. But then you get another job. You have no obligation to continue contributing to a project that you don't use. So I think my advice is that it's one of the best places to learn. It's where I learned a lot of things that were not available at the job. Our job has a very limited set of things they want you to work on. But in open source, you get to choose. So if there's a favorite technology that you wish that you could get experience on, that door is always open. I would say have a strategy and set a few boundaries.
So Civo Navigate is not only the just a conference. I have personally put in a lot of time making sure the schedule that looks like it comes out so that people who comes in, they learn something and go. So that's where the conference is different from the other conferences. Plus, it's not only Civo focused, it's a general technology conference. You have AI, machine learning, DevOps, platform engineering, WebAssembly, all those separate domains. The major difference between Civo Navigate Tampa and Civo Navigate in London has been the additions of WebAssembly, sustainability. So those are the key areas that we thought are very crucial with respect to technology and environment. So if you see the schedule, we have a good set of talks, sustainability panel, we had making cloud native greener, and then I think 5 to 6 talks with respect to WebAssembly, including a workshop. So I think that makes a good mix. Plus, doing it bi-yearly makes it, our journey smoother. Like we made a little bit of announcements regarding machine learning at Tampa, and we were able to do a lot more in the past 6 months and deliver much more. And then we can compare like from Tampa to London, how much we have progressed as a company, how much we are delivering in terms of projects as a company. So I think those set also makes the audience aware, okay, this is massive growth with respect to products, with respect to what Civo is doing in GPUs, machine learning, WebAssembly, logging, observability, and all that ecosystem. We have been doing a lot at Civo, especially with our machine learning service. So Kubeflow as a service goes to beta. So now you can try that. No need to get a request for alpha, and you should be able to try it. What that means is we have tried to abstract everything. So if you want to use machine learning, you should be able to get Kubeflow as a service. So you should be able to get there, create the models, train them, and add the GPUs and do your stuff. You should not be worrying about Kubernetes layer or any other layer up to that. So you don't get Kubernetes cluster, you don't get anything. You just get your machine learning dashboard Kubeflow, and you will be able to start your machine learning workloads, training and deployments and whatever you want to do. Then we have the VMs backed by GPUs. So when you create a VM, you can attach a GPU to it. So that is already there. So you can go create a VM, have your machine learning AI, ML or OpenAI, LLMs, whatever you want to run, you should be able to run that. And then in observability, we have we want to cover all the domains, obviously, metrics, tracing, logging. But we have started with logging. So we have, I showed the demo as well of the product launch. So we have a logging service in pre-alpha. So that is something there's an open telemetry agent that gets installed on all the nodes, which is there. And then it goes to the Kafka cluster, and then it goes to ClickHouse. And that's how our logging service is. And then there is a fancy dashboard with a unified query engine. So you can query for logs from all the pods, all the namespaces, filter it out, see the error info, all these things. So that is pretty exciting. And moving on to the next thing is the WebAssembly part. WebAssembly is something very close to me because I've been learning it from the past 1 year now, more than a year now. And it's the growth I've seen is pretty good, and especially the containerd shims, making it easier to run it on Kubernetes, and that's what we are focusing on. So I showed it how it looks like. It'll be in alpha soon. Then confidential containers is something we are very passionate about. We have good partnerships with Intel. Intel SGX makes it easier to run in enclaves. Our mission is to run the whole operating system inside the enclaves. And then I think the sustainability angle, partnerships with Deep Green, and all the heating up the swimming pools with the GPUs that is powered by Civo. I think that's really fascinating.
Yeah, my name's Mark Bjornsgaard. I'm the chief exec of a business called Deep Green, and we're building modular data centers and recapturing the heat, recycling the heat from those data centers. So data centers are nearly 3% of the world's electricity supply. So we use 3% of the world's electricity supply to power data centers. And at the moment, most of the heat that those data centers produce, something like 97% of the heat, the electricity that goes into a computer comes out as heat. Most of that heat gets ejected into the atmosphere. So we've set up Deep Green to capture that heat and put it to good use. So essentially using the electrons twice, recycling the heat. It's clever immersion technology, so the computers are fully immersed in a mineral oil. So if you imagine C-3PO in Star Wars when he has his oil bath after he's come in from the deserts, that's what we do to the computers. We take the heat sinks off cards, we do a few other bits and pieces to the computers, and then we literally put them in mineral oil baths. And we then pump that oil around a closed loop into a heat exchanger, and whatever's on the other side of that heat exchanger gets hot. So if that's swimming pool water, the swimming pool water gets hot. If it's a district heating system, so if it's there are 11,000 district heating systems in the UK. Those are centralized systems which heat lots of houses. Then we can heat the house for free as well. So the principle is pretty simple. It's moving heat is really hard, but moving data centers is actually relatively easy these days. Connectivity means there's lots of dark fiber. There's lots of fiber in the ground in the UK. There's actually more fiber in the UK in the ground than there is in the whole of North America. So connecting these things up is no longer controversial. And the reality is that we simply don't have enough electrons to build the amount of data centers we need in the next 10 years. We are going to have to reuse the heat if we're going to build the amount of compute we need. Civo are starting to use our first data center. So we announced our first one in Exmouth Leisure Centre. So we're heating the Exmouth Leisure Centre pool for free. And the Civo high performance compute platform is now going to be using our data centers. So when you come to Civo to render a movie or fold a protein or do anything else you're going to do with AI, then you're going to be doing it on Deep Green Kit. So we are scope 3 neutral, which means that we are accounting for the carbon in the computers themselves. So yeah, every time you use Civo now, you're not doing any damage to the environment, but even better than that, you're actually doing some social good. You're helping a pool out that would otherwise may have gone out of business. Since our 15 minutes of fame in March this year, when for 4 hours we were trending number 2 on Twitter, every single swimming pool and every single district heating system in the Northern Hemisphere has got in contact. So we now have thousands of megawatts of capacity where we can deploy to. If we could deploy something like 10 times the entire UK's data center infrastructure we could deploy into. It's really just a matter now of converting all of our legacy old data centers into this type of technology.
I'm Saloni Narang. I was previously with SAP and HP. Currently, I'm working as a contractor in Expanso. I came from India and this is Civo Navigate. Excited to be part of Civo Navigate. So this year in KubeCon EU, there were many topics around CNCF sustainability, and it attracted me a lot because it raised awareness that how much CO2 footprint carbon emission is happening, and how much our pods, how much our clusters are taking power consumption. So this technology fascinated me very much, and I came across this CNCF sustainability tab, where I came to know about the tools, like fascinating tools I must say, like Kepler, and another one was CubeGreen. So yeah, I talked around these tools and I explained about the Kepler, what Kepler do. Basically, it calculates the energy consumption of your pods by using ML programs and by the technologies like eBPF, and it gives you nice metrics, Prometheus metrics using Prometheus, and you can see all the traces, all the metrics using dashboards like Grafana. Another tool which I came across was CubeGreen, and by using Kepler and CubeGreen together, you can achieve a very good it is a very good combination. And what CubeGreen does is it helps you in reducing the carbon footprint by scaling down your clusters, by making your deployment sleep, making your cron job suspend, and at times you can make them awake. When you can just specify that, admin can create a CR and you can explain when your pods can be awake, sleep. As you all know, we don't need to run thousands of clusters when we have development, staging and production environments. I'm not talking about production, but yes, on development and testing the systems, we no need of running all the thousands of clusters together, because it produces really high energy consumption, produces really high carbon dioxide emissions. So I talked around these tools and CNCF sustainability tab and how we can make software development more greener. Kepler gives you a nice metrics, so you can always see which cluster is consuming more energy, and using CubeGreen you can create a CR and make those clusters sleep, make those pods sleep during that time. There is CNCF sustainability tab. Basically, it is a advisory group which guides you, which answers your queries, which defines which set of projects will come under this sustainability tab. So you can always get back to them, contribute, and they do have calls also on every Wednesday, I guess. You can just visit their page, CNCF Sustainability Tag, and look for that. You can join meetings if you have any questions. They're very quick, very nice people out there.
Hi everybody, my name is Ramiro Berrelleza. I am the co-creator, founder, and now CEO of Okteto, a company where we're building a platform to automate the developer experience of software teams of all sizes. I got a chance to talk about preview environments, which are like these environments you create on every pull request, and why they can be a great way for us to bring more people into the review cycle of code. You know how traditionally only developers can review a pull request, but if you create an environment for the pull request, that means that more people, PMs, QA, stakeholders, even your customers, can be part of this early feedback cycle. So we talked about that, very focused on how this helps you create more inclusive processes and how at the end of the day, this means you have better software. The main problem we solve is, every developer has this challenge where when you want to start building a feature or you're joining a new project, you spend a lot of time setting up all the things you need to get to work. Running services, databases, trying to get all your container images. So what we do at Okteto is that we build a platform that runs on Kubernetes, where you can automate all this for your entire team. You can think of this as a development environment as code kind of thing, where you have this YAML file that defines your entire developer experience, how to build your project, how to deploy it, how to develop. And then everybody that joins your project, they run one command, the environment is running on Kubernetes, and they can very quickly get to work rather than spending hours setting up everything by hand. I've been an engineer all my life. I've been using Kubernetes almost from day one, and that pain point will always kind of annoy me. So what we did is we started Okteto first as an open source project, where there's a CLI you can download from our GitHub repo. And the CLI, what it will do is Okteto up, one command. It will deploy your dev environment in Kubernetes, and then it's gonna create a tunnel, an SSH tunnel between your local machine and Kubernetes. It will give you a remote terminal into your containers, where you're gonna be able to do things like hot reload your code, attach a remote debugger, run your tests. And the whole idea of this is that you can make a change on your local machine, on your favorite IDE, and you're gonna see that change happen immediately on your containers on Kubernetes without having to do a commit, without having to rebuild images or redeploy your application. And then when you're done, once you commit and you push that branch and then you create a pull request, then Okteto also creates a preview environment for this pull request. So you can have another environment where your teammates or anybody else who's involved with your project can go see the whole thing running live, give you feedback, and then you iterate that way. And really, it's all really focused on how can you remove friction from the process, how you make it as fast as possible, so everybody focus on what makes their work special and not on this kind of like annoying tasks of deploying, rebuilding containers, waiting for things to be up and running. So what I want to show you today is our self-host solution. So Okteto is a Helm chart that you can install on any Kubernetes cluster. Once you install it, you get two things. You get a UI where like your entire team can like visually launch things, and then you get a set of services that are going to manage the life cycle of your environment. So you can do things like deploy them with one command, deploy them via GitHub, automatically shut them down when you're done, delete them when you merge a branch and stuff like that. So when you log in, this is the first thing you see. This behind the scenes will create a namespace, a service account, and everything you need to work on Kubernetes. And then when you want to work on your environment, you click the launch environment button. In this case, I already pre-configured my instance with all the repos that I'm working with. So today I'm going to show you the Okteto shop, which is one of our demos. You click on it, you click launch, and that's all it takes. At that moment, Okteto is going to spin up a job on your Kube cluster. It's going to go clone the repository. It's going to look for this Okteto.yaml that describes how to build and deploy your application. And then in a few seconds, you're going to have your own copy of the application running just for you. In this case, to save us some time, I pre-launched the application on a separate namespace, which is also one of my favorite features, which is because you're in Kubernetes, you can have multiple copies of your environment. You can have one, you create a namespace, deploy an environment, create a second namespace, deploy another environment on a different branch, the same branch with different code. You can share with other people. You can do whatever you want. But here we have this environment up and running. You can see on the left how Okteto is showing you all the components, the state. If I click on any of the components, you can see the logs, you can see the endpoint. And our goal here is to put all the information that you need as a developer right in front of you. I believe that, for 80% of the tasks, you should not have to do anything. And then sure, for that 20%, Kubernetes is running behind the scenes. You can do everything you want. So I have an environment here, and just real quick, I'm gonna go to menu service, click on it, and you can see that my application is running there on Kubernetes. And all I had to do was click one button. I have Visual Studio Code. You can see here that I have the Okteto YAML for this specific sample. And this is something that you can get up GitHub. You go to github.com/Okteto, and you'll find all of our samples there. And this sample actually mixes Kubernetes, Terraform, and AWS, just to show you what an environment looks like. So I'm gonna go to my terminal. I already installed the Okteto CLI. That is the only thing you need running on your computer. And you run Okteto up. When you run Okteto up, Okteto will analyze your environment and will ask you, hey, which microservice do you want to develop on today? In this case, the menu service. When I select a microservice, what happens is that Okteto is going to connect my local machine to this remote container. It will create a SSH tunnel. It's going to use a port forward and an SSH tunnel to make sure that your connection is reliable. And then it's going to start a file synchronization service between your local machine and the remote environment. For this, we use an open source project called Syncthing that has been around for a long time that is really good at fast incremental file synchronization. So you can see here on my console how the application is now deployed. Now I'm attached to it. In a second, I'm going to have a remote terminal where I'm going to be able to run my command. So for this example, just real quick, showing you the application. We're going to change something simple, a label. Like here, you can see that it says powered by Okteto and AWS. So instead of that, I'm going to go to my IDE. In this case, this is the menu, public, and I'm going to make a change. And what I'm going to do here is I'm going to change this is powered by Kubernetes and Civo Navigate, because we are at this amazing conference. I'm going to save my file. I go back to the terminal. You can see I have a remote terminal. But what's special about this is that this remote terminal is actually running on Kubernetes. If I do, for instance, who am I? You can see it's root, because I have root access on this container, which means that I can run the same commands as local, in this case, yarn start, but now everything's executing on my container. So if I go back to the application and I refresh, and you can see now it says powered by Kubernetes and Civo Navigate. And now let's make another change just to show you like how easy this is. Instead of saying powered by Kubernetes and Civo, we're going to go back to say powered by Kubernetes and Okteto. I'm going to save. I'm going to go back here. I'm just going to like refresh the UI. And you see now it says powered by Kubernetes and Okteto. And this is a small, simple change, but this is the core of our idea, right? Run everything in Kubernetes, attach the tools you use, in this case, Node, Helm, VS Code, but make it fast, make it easy, and make sure that everything is running remotely so that your entire team has access to the same tools without having to think about it. If you see what's really fast, I didn't build any containers, none of those things. If I want it, once I'm done, of course, commit, push, and then you create a pull request. And that's the other thing that Okteto gives you. I'm going to go back here real quick to the previous section where I have a preview environment. In this case, I'm going to open this pull request in GitHub. You can see that I make a change to use the official AWS CLI Docker image. But what you're going to see here is that I have an environment. I have links to the environment. And if I click on that environment, I can see a live copy of my application, which now I can send to everybody in my team for them to make sure that things work as expected. The open source version, which is the core of our product, is this will give you everything you need for you as an individual to start moving into this world of remote dev, test, and preview environments. The commercial product is meant for organizations, teams, companies who want to scale this up. You get user management, security policies, policies to like clean up, scale down your environments, and things like that. Like we plan to keep it that way because we want everybody to benefit from this idea of remote dev environments. But we also want to give organizations the tools they need to apply this at large scale. As you can imagine, a company with like hundreds of engineers has very specific needs around how to manage infra access that are very different from what I have on my hobby projects.
I'm going to try and convince people in 25 minutes that they should get rid of their CPU limits. No, I'm going to give a balanced perspective. I'm going to speak about the trade-offs of having CPU limits and getting rid of them. And I'm going to walk through and I'm going to show a little bit of proof this time. So sometimes people, I think there's a lot of confusion about how stuff actually works. So I'm going to take actual YAML snippets. I'm going to show the impact and like give a live demonstration of what different things actually do. And hopefully that helps convince some people. Last time we spoke, we had one main open source project. Yeah. And that's the flagship Robusta open source project. So we take Prometheus alerts and well, I'll show that in a moment. But that really relates to better Prometheus alerts. And then since then, we've released two other open source projects that have been really popular. One of them also is around Prometheus alerts and integrating AI into that and OpenAI and getting insights using large language models about Prometheus alerts and why they're firing. And the other one is KRR, Kubernetes Resource Recommender. And we look at your pods, we look at your historical data, and we tell you what you should set your CPU and memory requests to be, and how you can save money in your cluster. So we have two offerings there. So everything I spoke about up until now was on the open source. And then we also have a commercial platform that brings everything together into one solution. Yeah. And gives you a UI, and gives you a single pane of glass, and really is used by people who have dozens, sometimes hundreds of clusters, and need that single pane of glass for everything that's going on. And there, we're actually about to launch some really cool stuff with AI soon that we've been testing in private.
Yeah.
And the thesis of it, the gist of it, which we thought was a little crazy at first, but we think it's true. The gist of it is like this. You have a ton of observability data, you have a ton of metrics, you have a ton of logs, you have a ton of data. And actually, a big part of what's hard is just finding the right thing to look at. And if you go to an AI and you say to an AI, okay, here's an issue that occurred, tell me why this happened, tell me what you should do to fix it. Sometimes the AI will go off and hallucinate and make stuff up. But if you take all that data and you help use an AI and you try and say, what should I look at? And of this data, which is the part that's interesting, or which part could explain this error? And it just does a good job at picking out the bits that you should look at and then give human attention. Then you can get some really cool results that sometimes will show you stuff that you wouldn't have even seen yourself. Let me show this. On the first open source project that we have, our main project, we take Prometheus alerts that look like this. And you can, I don't know if you can come over and see. But here's a Prometheus alert where when a developer gets this Prometheus alert, this is about a crashing pod. And then in a normal enterprise organization with thousands, tens of thousands of developers, if an application developer working on business logic, who's an expert in applications, gets this alert, he's going to do one thing. He's going to tag the DevOps team, or the platform team, or the customer success team, or the SRE team, whatever you call them in your organization. Or he's going to go and open a Jira ticket for them. He's going to say, I have an issue here on the infrastructure. Can you help me fix that? And that's obviously really efficient. It increases the time to respond to things. And these are great developers. They should be able to troubleshoot stuff like this themselves, but you have to make it easier because people always take the easiest path. So what we do is we take this alert and we turn it into this. And now this is an alert that has all the data that you need. This has the pod logs, this has the stuff. You right away see that this is an application issue, not an infrastructure issue. So right away you've already been able to route this now. It actually is a developer issue. It's not a Kubernetes issue. And now the developer can go and respond to this. And we do that for a lot of different stuff. So like imagine you have a pod that gets killed because it runs out of memory. So we show here the graphs that we need to see in order to analyze that issue, in order to understand. So we help you fix those issues. And that's our first open source project. And we can even give you like remediation buttons to go and to fix stuff and to take actions based on that. And again, all the observability data is there. We're not collecting even. It's all there in Prometheus, right? With data on top. It's all there. We're helping make it accessible and showing the right data to the right person at the right time. The second open source project I touched on really briefly gives you a button here on these Prometheus alerts saying Ask ChatGPT. And we have a really cool version of this. I don't know if I'm going to show it now, but we have a really cool version of this in private beta now, doing that in the Robusta UI. We've seen really, really cool results on that. And then the third open source project that we have, over here, is, again, developers running on Kubernetes don't know Kubernetes often. And on Kubernetes, you have to set these four numbers: a CPU request, a CPU limit, which you don't set, but you set it by not setting it, a memory request, and a memory limit. You have to set those numbers. If you set them wrong, then you have horrible inefficiency. And Sysdig actually did a study, and they found that people were overpaying for clouds on Kubernetes by 69% by overallocating the CPU. So if you get these numbers wrong, there's big implications for the business, and everyone gets them wrong. So what we do is we look at the historical data, which again, the observability data is all right there. You just need to surface it at the right time. We surface that observability data, and we show that to people, and we show you, here are the deployments in your cluster. Based on the historical data, these are the resources that you actually need. So don't over-provision, maybe over-provision by 10% to have a safe buffer, but don't over-provision by too much. And that's why our last open source project does. This is the commercial version, and really it's taking, all that, like those use cases that we're solving, like each of the open source projects is solving a pinpoint use case, and it's solving a specific use case there, like around, I have Prometheus alerts, and developers want to respond to those, but sometimes they're missing information. I want to use ChatGPT to pull in extra information and see why these alerts fire. Each one, I want to know what the right resource recommendations are, and I want to like right size my workloads. Each of them is solving a pinpoint problem. By an enterprise level, if you're looking at an organization that, as one of our prospects recently said to me, has clusters popping up like mushrooms, and you're scaling it out, and you have dozens, sometimes hundreds of clusters in really big, fast-growing environments, then there are all sorts of other stuff around governance, around getting visibility, and we bring it all together into one coherent solution. And what we give you is we give like one solution for that. So let me just show you how we like improve some of those open source projects. So like here are the resource recommendations. But in an organization where you have many different people involved, you're going to another team and you're saying this is what you should change. And they say, well, how do I know that? So we show the proof on this. And we can show you like, here's the breakdown, here's the historical data to back that up. And we do the type of thing here in the UI that's hard to do with just a command line tool or just Slack alerts. And then we'll show you like across all your clusters, all the applications that you're running. We'll do like change tracking. So you ever have an issue where like something stops working and then you want to know why it stopped working. So I could like go here, here's an alert that's firing, the Prometheus alert that's firing right now. It's like an improved alert manager. I can travel back in time to the point where it started, and then I can see the change that happened on the cluster right before that.
That's right, I had a workshop and a talk yesterday. My workshop was on network foundations, taking a bunch of engineers through networking in the world of Kubernetes. And then my second talk was a security-focused talk around compliance, detection, remediation with tools like Kubescape, Istio, and Cilium. So it was a good blend to have networking on one end and then security on the other end. And then that was it. I was done, happy to be done because my adrenaline was high, and then I finally settled down and relaxed. Ambient mesh is actually a sidecarless approach to service mesh. It's another mode of Istio, and what it's aiming to solve is the operational complexity, reducing cost and resource consumption, and simplifying the onboarding of your services into the mesh. But how this is all possible is by removing the sidecar altogether, but shifting that function to the Z-tunnel. So the Z-tunnel primarily provides two key things: layer 4 policy and MTLS. And the reason why it does this is because between services, we still need to provide some level of identity and encryption for when they have to communicate, but we also need to be able to throw in policy when we want certain objects talking to other objects, while other objects should not be talking to certain objects. Now, that being said, the Z-tunnel was built with minimal configuration, minimal footprint, to keep it very lightweight, to align with the resource consumption bit. Now, when it comes to the observability, because we have TCP metrics available in the Z-tunnel, we're able to export that and share that with other observability systems like Dynatrace, or let's say we want to go very basic and look at Kiali, we have ways to do that as well. So when it comes to the Prometheus export stuff, the challenge is because it's so lightweight, we have to decide where we want to plug this in. So there are a few options. The one option is, because of the layer 7 functionality that existed inside of the sidecar previously, we've moved that to something called a waypoint. And that waypoint contains all of those layer 7 details, that telemetry, but it's deployed on a per needed basis. So when you decide you need that layer 7 observability, when you decide you want to enforce layer 7 authorization, you'll deploy the waypoint. Having said that, this is all open source. Now, if you decide you wanted to take your open source strategy and make it a little bit more enterprise, that's where Solo comes in, because with Glue Platform, they've been able to achieve, through their abstractions, how to achieve that Prometheus export using Z-tunnel. Because what it'll actually do is it'll actually leverage the abstractions on top of ambient mesh. It'll capture the telemetry data from Kubernetes and feed it into the Glue Platform observability piece. Istio 1.19 actually launched, I think, yesterday. So it just got released, and it's still keeping ambient in alpha phase because there are several reasons. One, we need to see more and more consumption of it. Like, the open source community needs to see more drivers, more environments leveraging ambient mesh in production. Two, the observability piece is still up in the air. Three, there are challenges around working with CNIs. So you have to pay a little bit more attention to how you get ambient mesh working with CNI technology. Solo has addressed this, by the way. But for the future of ambient mesh, I think it really starts to focus on other kinds of workloads. So we're going to see how virtual machines can have access to the mesh, much like how we saw with regular Istio. I mean, it's possible with normal Istio and sidecars today, But with ambient mesh, it changes the game because now you're using a Z tunnel as that proxy that lives alongside that VM to be able to connect back to the mesh.
I'm going to be on a panel about the future of open source with some amazing people. Amanda Brock, who is CEO of Open UK. I know her through Open UK. We've got Peter Zaitsev from Percona, and we've got Matt Barker from Venafi Jetstack. And I think it's going to be a really interesting discussion about what even is open source and where's it going? Because obviously there's a lot of changes have been afoot recently. Companies doing different things, and I'm sure we'll talk about the pros and cons of things like HashiCorp's licenses change. Cilium 1.14 open source was released, I think it was July, I'm going to say July or August, and it came with a load of really great new features. One that is particularly, I think is incredible is mutual authentication. So we've been able to encrypt traffic between workloads for a long time with transparent encryption, which uses IPsec or WireGuard to encrypt traffic kind of at the kernel level. But until now, we haven't had cryptographic authentication of the endpoints that are involved in different communications. So traditionally, or if you can say traditionally with service mesh, it's often been done using sidecar containers. So you inject a proxy into every pod so that that proxy can do MTLS on behalf of the workload, on behalf of the endpoint. What we're doing in Cilium is we don't need those sidecars anymore. The Cilium agent is going to take care of that authentication handshake, which is exactly the same handshake as happens in mutual TLS. But it's using identities that it gets from a pluggable authentication interface. We're initially starting with Spiffy in Spire. So right out of the box, you've got Spire included in with your Cilium deployment. So you can, with literally no effort at all, get these Spiffy identities allocated for your workloads for each pod. And the Cilium agent will take care of this handshake. And then the encryption is taken care of by IPsec or WireGuard in the kernel. So we've got all the benefits, essentially, of MTLS. We've got the mutual authentication and the encryption. Literally, all you need to do is add 2 lines of YAML to a network policy. It's so easy to use and so lightweight. The fact that we don't have sidecar containers makes it so much easier to operate. I think by the time this comes out, we will have already had eBPF Summit, so there will be a whole load of really great talks available on YouTube to watch from eBPF Summit 2023. We've got some great speakers. We've got Brendan Gregg, who is really known in the eBPF world for his work on tracing with eBPF. He's going to be doing a really great talk about why eBPF is so essential. We've got Joe Stringer, who's a maintainer on Cilium, talking about the future. And we've got Jean Yang from Akita, which has now been part of Postman, and she's going to be also giving us a really great keynote about eBPF. And then a whole load of other speakers as well. So yeah, do catch up with those videos.
My name is Andrew Maguire. I'm the ML lead at Netdata, Netdata Cloud, and we are a troubleshooting, monitoring, and open source agent. We've been actually around a few years. So our CEO Costa, he started the project about 2016 in his spare time, and got some traction. Actually, I think somebody posted it to Hacker News. It went viral. Community grew from there, and since about 2019 now, I think it's been full-time as a company, and so we've been working on it ever since then. We have on-prem and SaaS, and sort of you can actually install it on your own agents. So basically, install the agent on your nodes, and each agent has its own dashboard, and that's that's like a minimal you can do is you can just install the agent on your own dashboard. So we have lots of like home lab and Pi users, and then if you are like more like a business or an enterprise, you can claim those nodes to cloud, and you can also connect the nodes together. So you can have, not any node can be a parent or a child. So you can stream nodes to parents, and for bigger installations, then you can claim it all to cloud, and cloud can sort of straddle your whole infrastructure basically. And the data still lives on your nodes, and cloud just acts as like a gateway to pull the metrics and the data when needed. And then for more kind of if you have like enterprisey networks where you can't use SaaS, there's on-prem offerings as well. So you can. We have an on-prem offering at the moment that a number of big institutions that can't necessarily use cloud, or they have to use everything behind their own network, they can do an on-prem install. If the metrics are on like a standard port, that's kind of recognized within the default. So for, if that node has like has Redis running on it or has Nginx, it'll automatically discover and find those metrics. If you have maybe your own custom Prometheus endpoint, then that's an example where you might need to use the Prometheus collector to scrape that endpoint, and that's like a one-line config change. There's no more installation. That's like using the Go binaries that are shipped with the agent. So you can if you have your own Prometheus endpoints, you can do kind of scrape what you need. And likewise, things like containers and Docker, all that's automatically discovered as well. So if you have multiple containers running, they also get pulled in as well, and their metrics gets it's there. It's just there in Netdata. So when you open the app, you should see basically most of what's on your machine. When Netdata agent collects metrics, it doesn't just collect the metric and pass it on. It also collects the metric and sort of scores each metric. So basically, within the internal representation of each metric, there's a 1 or a 0, which is the recent data for this metric anomalous or is it normal? And once you have these kind of 1s and 0s, and they're built into the internal representation, so there's no kind of storage overhead for storing them, in addition to the metrics. Once you have these 1s and 0s, they become like a Lego block. So basically, for any point in time, you can ask what's the anomaly rate across all of your metrics, or across all of your nodes, or within any subset you want, basically. And then obviously over time, once you go beyond 1 second, you have an anomaly rate now. So the anomaly rate then can become kind of like a Lego block within the whole application. What it technically does is it like looks at the recent data and sort of featureizes it, which is an ML thing. And if it sort of sees a strange squiggle in the recent data, then it will compare that to what it's learned as normal, basically, and the distance between the recent data to the sort of reference models. That's what's behind the anomaly rate. And there's a whole actual right next, if you go to GitHub Netdata in the ML folder, there's a whole notebook that goes into this in Python that kind of walks through exactly how it works under the hood. So in here, I'm in the machine. Like we have spaces and we have rooms. So I'm in the Netdata demo space, and there's a machine learning room in here. That this is where I use to kind of, we have five nodes in here, 5 VMs, and it's typical enough. You have kind of overview tab, home tab, nodes tab, which kind of lists all the nodes. But really, the overview tab is the one that sort of aggregates all the metrics together. And so sort of you have a menu bar on the side that's kind of semantically organized. So you have topic areas like system overview, which is just general metrics. Then you have specific stuff around CPU, a lot of the physical things, and then also like when you have the auto discovery. If I go back in here into there's all nodes room, it has all the nodes. There's we can see here some of these nodes have Apache, and so you have all the Apache metrics out of the box. Some of them have Cassandra, Nginx. You can see there's Postgres as well. So it'll detect this Postgres, and kind of you'll get all the Postgres metrics out of the box, and they're just there for you. And then in terms of the ML stuff, one way to summarize a node is using this anomaly rate. So we have typical metrics here as well, but we also have the anomaly rate for each node. And you can see here in this example, this is now the anomaly rate across all 5 of these nodes over this 2-hour window here last night, basically. And we can see that there's a spike here in the anomaly rate that was went about 3% of the nodes metrics, all their metrics went anomalous. So I can drill in and see, okay, which node is that? Because there's 5 nodes here, I need to know which one. it looks like in this case it's maybe three of them at the same time. And so I can now ask, okay, down below this chart I can see like it was what's driving this anomaly rate. So I can see here there's some file system stuff going on, and that's kind of like the physical subset of metrics that are most anomalous. But there's different ways to now look at this. I can press this anomaly rate button here, and that'll sort of light up the side menu. So instead of having to use my own idea to have a look and navigate here, I can kind of have a look and see, 7% of something within memory went anomalous. And I can see here that actually it looks like page cache, which when I go to the page cache chart, which is in this section here, it doesn't take you straight to the chart, it gives you the section. You can see this one here is anomalous. So there's some dirty page cache. And another way to do this as well is if you go to the anomalies tab, you can kind of have a more bottom-up approach. So in the anomalies tab, you can actually look at the same thing, and here we see the same bump in anomaly rates broken out by each node. And then we can actually, once we highlight an area, we can see which metrics were most anomalous. And in this case, in this demo room, we actually have a file stressor user who's like a bad user that wakes up every 6 hours or every 12 hours randomly and runs lots of file attacks using stress-ng. So you can see here actually that it's automatically detected that the stress app, which is what stress-ng gets mapped to, came alive and took up a couple of hundred megabytes of memory basically for a little period, and that got flagged then as anomalous behavior. So this is like a sort of a bottom-up approach to the anomaly detection. The open source agent is on GitHub. It's open source. It's installable by anybody. Basically, you can run the agent, one-line installer, and then if you want, you can claim that agent to Netdata Cloud, or you can actually just have it as your own self-hosted agent. This is an agent that's just I'm on the node itself here, so that's where you can see local. This is like the local dashboard, and it's literally the same dashboard as Netdata Cloud, and the local dashboard pulls down the latest version, and this is so you have most of what the cloud is out of the box by definition. Come and there's a community. We have a Discord, we have a community forum. So if you go to Netdata Cloud /community, you'll kind of see the links to all those guys. There's basically Discord, forums, GitHub discussions. We'll kind of meet you where you're most comfortable, basically.
That's it for today's episode related to the conference Civo Navigate Europe. As you can see, lots of great speakers were here, a lot of great talks, well organized in a beautiful area. So if you enjoyed today's content, don't forget to like and subscribe to the channel. See you soon for another traditional episode on a technology. See you. Bye.